All right, we're going to work with linear and angular speed. Please pause when you need to. So a carousel contains 4 circular rows of animals. As the carousel revolves around, the animals in the outer row travel at a greater distance per unit of time than those in the inner row. So if here is your carousel, you have an outer row of animals, and then inside of that is another row of animals. And notice the difference that this outer row has a greater distance per unit of time than those in the purple. These animals have a greater linear speed than those in the inner row. So these are going to go faster. Regardless of the row, they complete the same number of revolutions per unit of time. All animals in the 4 circles travel at the same angular speed. So what I've highlighted in the yellow is we're going to use V for linear speed and W for angular speed. So we're going to go ahead and define those on the next slide. So please make sure you pause when you need to. So the first yellow box has the definition of linear speed and angular speed. So the first formula is linear speed. It's denoted by the letter V, and then the S is your arc length in radians, and then T is your time. So we've done that S earlier in our unit. That is our S. So then to find angular speed, we would use the letter W. Here's angular speed. And then you have that angle theta in radians. It cannot be in degrees. And then T is your time. Down below in the second yellow box, linear speed in terms of angular speed. Linear speed is denoted by V of a point distance r from the center rotation, where W is the angular speed in radians per time, per unit of time. And then W is your angular speed. So let's go ahead and practice this. So here's an example. A wind machine is used to generate electricity that has blades that are 10 feet in length. So here's our 10 feet. That is going to be our radius. The propeller is rotating at 4 revolutions per second. So imagine this propeller. There's 1 revolution. Here's a second revolution, 3, and then 4. So that would take 1 second to move around 4 times. And what we want to do is find the linear speed in feet per second. So we're going to do this in steps. So let's write what we have. We have our radius, which is 10 feet, not inches. We have our 4 revolutions per second. So that is our W, which equals angular speed. And that is 4 revolutions per 1 second. So step 1, we have to express our angular speed in radians per second. Notice here it's revolutions per second, not radians per second. So for you to move one revolution around, that distance is 2 pi radians. So we're going to be converting that using a ratio. So 1 revolution equals 2 pi radians, or I think 360 degrees. So we're going to go ahead and convert. W equals angular speed 4 revolutions per 1 second. That was given to us, and now we're going to use this equivalent. 2 pi radians is equivalent to 1 revolution. And now we're going to simplify these two fractions by multiplying across. The revolutions will cancel. So 4 times 2 pi is 8 pi radians. 1 times 1 is 1, and then second. So our angular speed is 8 pi radians over 1 second. All right, step 2. Step 2 now, we can use our linear speed formula, which is written here, and then I'll go up to that yellow box for you. So here's our yellow box. This is the formula we're using. We converted that W to angular speed in radians per unit of time. So we did this W already. So now we're ready to substitute in. So linear speed equals the radius of 10 feet times our part 1, 8 pi radians over 1 second. And now we're going to go ahead and multiply across. 10 times 8 is 80 pi feet over 1 second. You can also plug that into your calculator, and it's approximately 251 feet per second.